So welcome to my talk about container migration news. My name is Adrian Reber. I work at Red Hat since 2015. I'm involved in process migration, which is the basis for container migration for over 10 years, I would say. I'm in some way involved in CREO, which is the tool which process and container migration, which I'm talking about today, is based on since about 2012. I first used it, heard of it. And since 2015, I'm focusing more on container migration than just on process migration. I included a link to the slides here in my slides, which is probably not helpful, but it should also be in the chat, I guess. So the agenda for today, I first want to give a short technical background about process migration, and then I want to talk a bit about how RunC and CRun both support checkpoint restore to migrate containers and where differences between CRun and RunC are. And then I want to talk about a few new Podman container checkpoint restore related features which appeared in the last year. And then I want to, at the end, talk about Cryo and checkpoint restore and container migration, what I'm currently working on. So technical background. So everything I'm doing here, I'm talking about, is based on CREO. CREO stands for checkpoint restore in user space. And the reason why it has the name checkpoint restore in user space is that probably over 10 years ago, there was an approach to get checkpoint restore in the kernel, and this wasn't accepted at the time. And then the other approach, which is used most today in Linux, I would say, is CREO. And CREO, in contrast to being in kernel space, it's done in user space. And in user space means CREO uses existing information which is accessible from user space. And one of the important things for CREO is proc_pit. There are a lot of information there which CREO collects to be able to checkpoint and later restore the process. Then CREO also uses ptrace to stop the container, but it also uses ptrace for the last part, which is called the parasite code. Using ptrace, CREO injects the parasite code into the process to be checkpointed, and the parasite code then runs in the to be checkpointed process. And the parasite code is then running within the process address space and can access everything the process can access. And so it's easy for the parasite code to get to certain information which is not available through proc_pit or which is slow via ptrace. So the parasite code is one of the important elements of CREO, how to checkpoint and restore processes. So CREO and containers. So what CREO does is when you tell CREO to checkpoint a process, you tell CREO which PID you want to have checkpointed, and CREO then checkpoints that PID and all child PIDs. So CREO will always operate on a process tree, never on a single process, except if the process has no child processes. But it will always operate on a process tree. And in the end, containers are just processes, and CREO checkpoints the processes you tell it to, but CREO also collects information about which namespaces the process has, which seccomp rules, SE Linux information, and all that information which makes up a container are also checkpointed and restored by CREO. And on restore, CREO will use that information to restore the process again in a container with all the things which make up a container. So the next topic is RunC and CRun. So I want to look at checkpoint restore related features in RunC for maybe the last 12 months. And one of the important things from my point of view was the ability for RunC to checkpoint processes out of an existing PID namespace and restore into a new PID namespace. Before, CREO would always dump a complete PID namespace and restore the complete PID namespace as it was during checkpointing. But as I started to look into checkpointing containers out of pods, I needed CREO and RunC to be able to checkpoint processes out of PID namespaces and into new PID namespaces. And this is something CREO and RunC can now do. And CREO and RunC can also handle all the other namespaces to checkpoint and restore out of them. But the PID namespace was special because CREO on restore tries to recreate the PIDs with the same PID, the processes with the same PID they had during checkpoint. And so there's some additional work for the PID namespace necessary to make this work. And with the support to checkpoint and restore out of PID namespaces, I can now use RunC to checkpoint container and restore containers in CRI-O, which also enables me to do the same with then Kubernetes if it uses CRI-O. There's one thing still missing to use RunC in combination with Kubernetes. There are, if you have nested bind mounts, then RunC does not yet restore the containers correctly, or CREO does not restore the containers correctly. But there's a pull request open to fix this, so I guess this is just, it takes some time to get merged. If I now compare this with CRun, so about, I would say maybe 1 or 1.5 years ago, there was a ticket created in CRun that it does not support checkpoint restore, and I started to work on it. So the difference is between CRun and RunC. The one is in C, the other one is in Go, and all the calls that RunC does in Go to talk to CREO were not yet available for the C interface. So we had to first do it in CREO, and once that was done, we can now use CRun to checkpoint and restore Podman containers just like with RunC. And what I basically did here is I just replicated the RunC checkpoint restore API, if you want to call it an API. But CRun now just behaves the same as RunC if you want to checkpoint a container. There are still a few things which CRun cannot do. So RunC supports Precopy Migration, so you can first do a dump of the container, write all the memory out to disk, then transfer the dump to the destination system. The container keeps on running, and then you do a second dump and just dump the pages which have changed. So this is something RunC can do. CRun cannot do it yet, but it shouldn't be complicated. It's just someone has to implement it. It's not hard. And this is especially interesting because there was Podman recently has support to use Precopy Migration to migrate containers from one host to another. What CRun also cannot do yet is post-copy migration. This is also to decrease downtime during container migration. You do a dump, you do a minimal dump, transfer to the destination, and then once the destination accesses a memory page, it goes through user_fault_fd, and user_fault_fd goes to CREO and fetches the page from the source system to the destination system. So combining post and pre-copy migration should decrease your container downtime during migration. As far as I know, nobody uses RunC's post-copy migration yet, so it's not really, we're not in a hurry to implement it also in CRun. Then all the things I talked about, pod migration, checkpointing out of and into PID namespaces and nested bind mounts is also not yet possible with CRun, unfortunately. So my next topic is new Portman features during the last years, new Portman checkpoint restore features. And One of the things I already mentioned is the pre-copy migration support. So Podman now has the ability to do a pre-checkpoint. You can transfer it and then do the final checkpoint, which hopefully is smaller if your application does not change the memory pages too fast. I'm especially happy that this was a feature added by the community. So it's nice to see that there's interest in checkpoint restore in Portman from the communities. And so this is one of the things which appeared. Then the other thing which Portman now supports is volume support. So I'm not sure what the correct name is, but if you have a container with I think it's called unnamed volume, so you do not mount a host directory into your container, but just there's a volume defined in the container file. And before the feature was added into Podman, if you try to checkpoint a container with a volume, then Podman would just say, no, I don't know how to handle this. And now Podman just does a tar of the volume and includes it into the checkpoint archive. So when you do a checkpoint of a container which has a volume, the archive will contain all the volume data. And if you transfer that archive to another host and restore the Podman container there, all the data in the volume will be restored and will also be there after the migration. So, and now to my last topic here. So this is about CRI-O and migration. So getting checkpoint restore into CRI-O is motivated by getting it somehow into Kubernetes. So the first step was to see if I can implement it in CRI-O. And what I did is I basically took all the code from Podman, which does checkpoint restore, and added it to CRI-O. And after some changes, it worked. And I even just recently had a pull request merge so that I do not have to copy the code from Podman to CRI-O. I moved some of the code which Podman uses for checkpointing to a package, and I can now vendor it into CRI-O. So it's not so much code duplication. I can use the same functions in CRI-O and in Podman. And another thing which is important, which didn't exist in Podman yet, is how can I checkpoint and restore a pod, a container out of a pod, a container into a pod. And so basically, if I can restore a container out of a pod, and if I can checkpoint a container out of a pod and restore it into another pod, I also have pod checkpointing working. So because what I did is, if I do a pod checkpoint in CRI-O, I basically do a checkpoint for each container, and then I save some metadata about the information, what makes up the pod. And on restore, I'm not restoring the pause container, which holds the namespaces open. I'm just creating a new pause container. So this is not checkpointed in restore. And then I'm restoring the other containers into the namespaces of the pause container. So this works a bit differently. The pause container is handled differently than all the other containers in Podman and CRI-O. And so I have prepared a short demo. So I first want to show a few things in CRI-O. So I have nothing running here in CRI-O. So let's create first a pod and a container. I prepared some lines here. So this is the line I created. So I'm creating a pod, and then I'm creating a container in the pod, and then I'm starting the container, and the container in the pod is running a Wildfly application and it's stateful, because if the application is not stateful, then it does not make much sense to migrate it. So So it's a stateful Java application. It takes some time to start up. I can quickly restore it once it's running. So let's start up the application. And so now I should be able to see my container running here. So I'm just making it one font size smaller so that it doesn't fit on one line. So now I'm talking to my Wildfly container. So I prepared the complicated lines here. So what I do is I just do a curl, and then I get the IP address of the container, or of the pod here in this case. And the Wildfly containers are running on port 8080, and the application is hello world, and it will return a number, increase it, and the second time I talk to it, it will increase it. So it's a stateful container, and now I can say cry control, checkpoint, and I say, I prepared it here, so that's easier. So cry control checkpoint export, and I call the export archive, I call it cry.tar. This is just a container checkpoint now. It's not a pod checkpoint. So, and then I just tell CRI-O to use the container ID to checkpoint it. So let's checkpoint the container. Take some time, unusually long. Okay, so now I will, the container, I will now delete all the containers which are running here in CRI-O. No pods and no container running. So now I say cry control restore. No, I did it this way. Okay. So I say, so that I have the variable here, I say cry control restore, and I not say Portman tar. I say CRI-O tar. So now restoring the container, okay, this will not work because I did not create a new pod. So I first have to create a new pod. I'm creating a new pod. It has a new ID. And now I can say restore into the just created pod. And now it's restoring it. And if I now look, so the container is again running, and if I now access it again, it should return a 3 instead of a 0 when it started up from the beginning, and it does. So now I have restored my container in CRI-O, just like I can do in Podman, and I just want to show one more thing. I can say Podman run a container, and now I want to migrate a container from Podman into CRI-O, and because it has to use RunC in CRI-O, so I have to tell Podman also to use RunC. So now I'm starting another stateful container. This is basically the same application as the Java container. It's just now written in Python, and I can talk to it now using the same command, but I now ask Podman to give me the IP address of the container, and it's now running on port 8088, and it returns a number. So it's a stateful container. And now I can Podman to checkpoint that container, Podman container checkpoint, and I tell Podman to use the last container it is aware, and I tell Podman to keep the container running, do not exit it after checkpointing, and then I tell to write it to an archive here. I call it Podman tar. So now it's being checkpointed from Podman, and I can continue to access the container, so 5, 6, 7. So the container keeps on running, and now I can restore the container into CRI-O, but first let me show you, there's a tool I created to look into container archives. That's just to make my life easier. So if I now look at the Podman container, it will tell me the name of the container, it will tell me the image, the ID, the runtime, when it was started, and I think, I don't know if you still see this, but it tells me the checkpoint size. So the last column tells me the checkpointed process takes 8.4 megabytes on disk. So, and I can also do this for the CRI-O archive, and it will tell me it's created by CRI-O, and you see here it's much bigger because it's a Java application, so it takes much more space to get checkpointed, and also it contains rootfs changes because the Java application changes rootfs. The Python application doesn't change the rootfs. So let's restore that container into CRI-O. Container, something like this, yes. So now instead of the CRI-O archive, I tell it to use the Podman archive. And so now the container seems to be restored. Let's see what cry control ps says. So now we have two containers running here. One is the counter, which is the Python based, and the wildfly hello is the Java based. So now let's talk to the original application. So it still is running here. It returns the number as before, but now I'm talking to the container which I checkpointed out of Portman and restored into the pod in CRI-O, in the same pod. And now I can use the same IP address on a different port. Now my other stateful application is also running in the same pod, and with this I can move running containers from Portman into CRI-O. And with this, I'm at the end. Thanks for your time. Are there any questions?
I think I do see a couple of questions. I'll start from the top.
Okay.
So Lee has a question. Let's say he asks, could CREO potentially be used within CRun alongside libkrun?
Can it be used inside CRun alongside libkrun? I don't know. I don't know. Sorry. Probably yes, but I'm not familiar with that enough. But if it's in the end effect, if it's a process, CREO can probably checkpoint and restore it. I've been able to checkpoint and restore QEMU as long as it doesn't use the hardware acceleration, but then you probably won't use it. But in the end, CREO can checkpoint restore any process which doesn't use any hardware feature directly.
Thank you. Then I know Cesar had a question. I think Kara was trying to answer maybe, but I'll ask again. What are main use cases you were seeing for CREO in the field?
So there are three use cases. Basically, one is I want to. So it's always about you have a stateful container, and if you don't have a stateful container, you probably do not need a checkpoint restore and migration. But if you have a stateful container, stateful can mean you have some data in it, or it takes forever to start, or things which take time to appear in your application. The one use case is I want to reboot my host because there's some security update and I do not want to wait for the container to reinitialize. So I just checkpoint it, do a reboot with the new kernel, and upon restore, it's back again at the same point. I do not have to wait for initialization or load data additionally from disk. So of course, CREO has to load the data from disk, but once it's loaded, it's all there. That's one possible use case. And the other one is it's also connected to fast startup. I have one container and I want to create multiple copies of the same container. It's already initialized, so I can create one checkpoint. It can keep running or not, and I can create as many copies as I want of that one container. And the third use case is migration, the topic of my talk. I have a stateful container and I want to move it from one host to another host. Reason may be, I don't know, failover, maintenance, but also scaling out, scheduling. So we know from CREO, we know, for example, that Google uses CREO in Borg to move long-running tasks off nodes so that high important tasks can run on the hardware, but long-running things which are not important to finish right now, but you can move them somewhere else. They can continue to run, but you do not lose like 2 hours or 3 hours, which the process already run, and process data, things like this. So those are the use cases I'm aware of.
Thank you. Since we are at time and season,